Hi. As you probably saw from the thumbnail and the title of this video, this is going to be a little bit different than what you're used to seeing on my channel. I've been wanting to do these kind of more documentary style videos for a while, but it took some time to get comfortable enough with my gear and to muster up the courage to actually start contacting people about this. And I think I could do a 30-minute monologue about why I want to do this kind of thing and why, especially in EURORACK, I think it's really interesting. But because this video is already very long, maybe I will tell you some other time. Just a quick note before I start the documentary. Originally, it was the plan to shoot everything on one day. The idea was to shoot the complete assembly of an MS-22. So really starting off with the PCB material and going through the assembly process and then on to calibration and quality control. But as the day that I went to Threetom Modular seemed to be the most humid and hot day of the year, after about 3 or 4 hours of shooting in very warm conditions with extra studio lighting, we both felt as if we were starting to decompose, so I will be back there to shoot part 2 of this documentary where we do the calibration and quality control in his audio laboratory. Of course, while assembling we talk about several subjects, but instead of me telling you what we talked about, I'll just start the video and let Tom do most of the talking. I really hope you enjoy this video. So here we are at the workshop of Threetom Modular with the man himself, Tom. First of all, thank you very much for welcoming us into your space.
Yeah. This is you're actually the first visitor from YouTube. It's kind of exciting.
Okay. Yeah. So I think most people will know you from your 4 HP MS-22, which is a kind of filter that's based on the MS-20 filter, at least the second revision of that filter. Can you give us the short version of how that filter came to be?
All right. So back in the day, I was getting into EURORACK. It turned out that EURORACK was quite expensive.
Yes.
And so I also learned that there's things like DIY kits and stuff. And I went into DIY because I had quite a bit of test equipment and soldering gear in my house because I'm an engineer by trade. So I have these things still from back in the day when I was a student.
Like that.
I had built a few kits yet, and I somehow got talking to Steve O'Here, who at the time was a reporter for TechCrunch, yeah.
Okay,
and
so that's who Steve is.
That's who Steve is.
Yeah, I was always wondering who is Steve.
I got to know Steve because he was posting on Facebook asking about, hey, can somebody build me a kit for this MS-20 filter?
Okay.
But I got talking to him, but because he was in the UK and I'm in Belgium, it was not that interesting. It was too expensive to ship it back and forth.
And what year are we talking about? Was it before Brexit?
Before Brexit, so...
Yeah. So even then,
over 3 years ago.
Yeah, okay.
Because Threetom is nearing 3 years as a brand. So we got talking nevertheless, and Steve is actually he has some physical limitations.
Okay.
And because of that, he doesn't have a lot of reach with his arms.
Okay.
And as another consequence of that, he could only have one single row in his rack, and for that reason he needed all modules to be very compact. Yeah, so we got talking, and he said, yeah, because of my situation, ideally this filter we were discussing about building was an 8 HP filter, and so he said ideally I'd have this in 4 HP because of my situation.
Yeah, that was the room he had left in his his rack.
And then I said, yeah, I can probably do that because I design electronics for a living, or have designed.
Challenge accepted.
Yes, and then I also decided, but well, this is too easy, so I'm gonna add twice the amount of filter, and also this modulation matrix to make it more of a challenge.
So what do you mean with twice the amount of filter? Do you mean including the high pass as well?
Yes. Okay. So in that one kit he asked me to build at the time, that was only a single filter core that you could switch between low pass and high pass.
Okay, so you really need two to get the full MS-20 experience. Okay.
And then because I'm a culture barbarian, I didn't know what the original order of the low pass and high pass filter was in the MS-20.
You reversed them, right?
Yes.
Yes.
So I would like to say it was intentional, but it totally was not.
I wonder if it matters though.
In the end, I think it's interesting that the high pass filter in the MS-22 is the last one in series.
Yeah.
Because there the resonance of the high pass can be used to give a bass boost at the end of the line.
Yeah, but
before being clipped.
And that's a trick that's well known on the original MS-20 to do that, even if it's before.
Yeah.
So
indeed.
But I guess the behavior is a little bit different because it's behind. I did that comparison video, but my version of the MS-20 is the one with the Quark IC35. So those are the original filter chips that Quark designed themselves. And in the later revisions, they reach for over-the-counter, or what's the term?
OTAs.
OTA over the. Is it over the on the counter?
No. So,
under the counter.
So OTA stands for operational transconductance amplifier.
But they were
so those
cheaper.
are components that are used in many other things.
Yeah. Okay. What was it? Operational
transconductance amplifier.
Okay.
So that means that it converts a voltage into a current. So you'll get a current that is linearly scaled to the voltage that you put in.
Okay, but it's completely possible that the Quark IC35s are
they're
OTAs
doing
as well.
something similar.
Okay,
but
yeah.
For sure, it was much more expensive to make custom chips for that purpose than just using something that's commonly available.
I get the feeling, I think I read it somewhere, that you cranked everything up to 11, the gain and the resonance and the drive. Was there an idea behind that, or was it just to challenge yourself?
There were a few things. So I did find that you could say that my resonance control was not ideally tuned yet. But I also found that because I cranked it quite a bit further than the original, that in the second half of the control, when it becomes fully self-oscillating, that it becomes this really interesting drone box.
Okay.
And so it seemed to me that it would be a loss to not include that.
Yeah.
And I totally understand when people say like, oh, once it's past 12 o'clock, it's super loud, the resonance. And then that's a valid comment.
Yeah, it is loud.
But that second range of the resonance control is so interesting and so chaotic that it would have been a shame to not put that in.
I think it makes the filter much more unique than just being a one-on-one or trying to be a one-on-one
I never
clone.
tried to be a clone.
Yes. So you earlier told me about how you got to design the MS-22, but it seems to me that you bridged quite a large gap in quite a short time. Like you said, Threetom Modular is nearing its 3-year anniversary, but 3 years is really short. I mean, I see a lot of small makers who design stuff and try to sell their modules on sites like Etsy or reverb. Some of them barely make it onto modular grid. And somehow you managed in a really short time span to, I think, be pretty well known amongst the EURORACK community on several continents across the globe. Of course, building a good product, building a good module, something that's exciting, is an important factor in this success. But do you know what your secret is?
Ooh, the secret. There's a few things. So I did design my product to be easily manufacturable, even though it's very small scale. That helps a ton. But that's not why I'm well known, of course. But
that makes it easier to get the product out there.
Yeah, that helps. Even though there is still quite a waiting list. But what did help a lot in the beginning, and so when I was looking at other makers that were in the same boat as I was at the time, I did see that they barely put any effort into marketing and into making proper videos of their own stuff when they didn't have budget to have somebody else do it. And so I did invest quite a bit of time into making those videos. I had to learn how to edit videos and stuff like that in a hurry. And then I also used to post these funny Photoshops with the MS-22 or with other things, and that garnered some attention. And then I think that led to getting a bit of following in the beginning, and I also shamelessly spammed it everywhere I could. And then of course my filter also got featured by a few people on social media. Minor Melodies being one of them. That had quite a bit of impact. And then there's many videos out there now, which in the long run I think does help quite a bit, that if people type your name into Google or YouTube, that they find stuff, so that they get a sense of this is alive, this is documented, other people are using this and they're happy.
If a maker hasn't the ability to make videos themselves, I as a video maker of modules, I think it's really important to let someone else do it.
The thing is, if we're honest, we ourselves as consumers, if we're gonna buy something, and especially in the EURORACK community, I find that not a lot of people are comfortable with returning stuff they're unhappy with, especially to small makers.
Yes.
It's also not always an option.
Yeah, no.
That they really want to know that this is a sound way of A, spending their money, and B, if it does turn out that they don't like it, that they can still, they're still able to get rid of it, because that person buying that is going to have the exact same worries as you did initially.
Even if there's a little cut to what the price is, for sure. I have been there countless times. So that's really important. Somewhere along the line, you have to have decided that you want to work with aluminum front panels.
They're not aluminum.
Okay. It's not PCB material. It is?
It is. But it is thicker than normal PCB material.
For sure.
Yeah. You can also make transparent windows into the front panel itself. And that is something that's not possible with the aluminum front panels. So with, Make Noise, for example, Morphogene, that has these really fancy indicator lights with many weird shapes. Those are also made out of PCB material, because that's the only way to make it. So I got inspired by the Morphogene because I was wondering how their illuminated... how their indicator lights worked, and I ended up writing a tutorial about it, which is still on the Threetom website.
Yes, it's quite in depth. As a brandmanie. So, Can
you see it like this?
Let's see if we can see 3 toms in one frame. We can. Should I light it up?
Yeah, it will be difficult to expose, but that's the annoying thing. So for it to look good to us humans, it needs to be quite bright, and
Yes.
so that's how I engineered it.
Yes.
But then to expose that on video together with other modules with ambient illumination, that's totally pain in the ass.
So this material here is the same one as this. It's just etched away
and with the difference that this is a bit thinner. So for the MS-22, it's thicker.
Yeah, it's really heavy duty.
Because it does cost quite a bit extra to have the thicker material, and for the modules I think it's absolutely worth it. But yeah, this thing was Spielerei, so it was a little experiment, and so for that reason I didn't throw the extra money at it. So I thought that since you're here anyway, let me show you how MS-22s are built.
Okay. Yeah.
That will be nice for you to see and for people watching your channel.
Yes.
I have 2 PCBs here. I think we should be able to show most of the process.
Yeah.
So we're starting here. The first step is the paneling. So the PCBs, they get delivered with all the small components pre-assembled. So they come like this in a panel. And as you can see, these are the 4 PCBs, but they're still joined together.
Okay.
So these need to be depaneled, as that is called. And that's what I do here with this machine.
Okay, so you have a machine to cut them apart from each other.
So I used to do this with this manual tool in the past, so that works like this. But it's very heavy on your hand, and after 5 panels your hand hurts like hell.
I can imagine that.
Also, it's very slow. You'll see this goes quite a bit faster. So when cutting PCBs, there are some small fibers coming free in the proximity. So although I never really had issues in the past, because it's only recently that I'm starting to wear a mask while doing this. This is just erring on the side of caution.
Better safe than sorry, right?
Yeah, exactly.
Yeah. It looks kind of what's the
steampunk.
Steampunk, yes.
So normally when I do this, I have a rack with all the PCBs in them.
Yes.
But now, because it's only 2, it's just in the bubble wrap.
Okay.
So, are you ready? Start the clock.
Yes.
And voila. So then when that's done, you still have these little burrs on the end.
Yeah.
Because if people touch the module, it's not a nice feeling. So
yeah. Okay.
Before I continue, they get a little touch of an engineer's file, so that the modules feel smooth to the outside. I got this file when, on a whim, I decided to also get a degree as an optometrist in parallel to doing a PhD.
Okay.
But that did not work out that great.
So optometrist making glasses.
Yeah, my dad has an optician shop.
Okay.
So we thought it might be interesting for me to have that degree as well.
to go into the family business.
You never know.
Yeah.
And because I'm also an optical engineer by education,
Okay.
I had a lot of exemptions for the theoretical part of the program. But yeah, it turns out following lab courses in parallel with doing a PhD and being a teaching assistant, timing-wise, not a great combination. and so in that context, I got this file to file glasses, and I still use it to this day.
That's nice. That's nice. So you just filed the bursts of the PCB material?
Yeah, and so now they're ready to be assembled, and to do that properly or effectively, I use a soldering jig, and I'm gonna show you that in a minute. Alright, so we're here at my soldering bench, and by the time I got here, I realized that whenever I do a small run, I forget that I shouldn't do the depaneling first. So I will explain to you how it normally works, what should happen before depaneling.
Okay.
And then I'll just continue on assembling these two modules.
I completely confused you with my presence.
Yeah, your charm is mind-blowing, Simon.
I'm sure it's that.
Yeah. So let me briefly show you with some other PCBs that are still not populated. So these PCBs, they go normally also in a rack, so I don't have to mess with the bubble wrap. So these PCBs go into this soldering jig, and then I have these little fitting jigs, and so I can pick the connectors that should go in on this PCB, and so these are the other gender of what is being soldered.
Okay.
This is a great tip, by the way, for people building small amounts, small builders. This is a jig made out of the PCB itself, and the connectors are just soldered on the wrong side and with the wrong gender. And that allows me,
of course,
to immediately plug all those connectors, to put them all on the right place.
I see.
Then the soldering jig closes.
What?
Flip.
What? What? I think you have to show this. Wait, this is like...
Your surprise should not be cut out.
Okay, let's do it again.
Right. And so all the connectors that need to be soldered are on this little sub-jig.
Yes.
That allows you to quickly fit all of them onto the PCB.
And then you turn it around,
then the toaster, as you call it, Simon,
and
closes.
then something magic happens.
And so there's foam here that presses this gently down. Then
what?
The whole jig flips.
Okay.
And now I can see the contacts that need to be soldered. And because of this jig, they're all perpendicular. They're not out of whack. So I will show you how these
Did you design this? Did you
No,
design
this is
this, or
something
is
you
this...
can buy.
Okay, so a lot of people are...
I don't know how many people are
but
using it.
At least some people are using this.
Should probably be using it.
Okay, that's cool.
So what I'm gonna show you, the technique is called drag soldering. So I have this is my drag soldering bit. So this is very counterintuitive, because you think, oh, all these little contacts, you're gonna need a small soldering tip. But then if you were to do that, you'd see that you'd be soldering like this. 1, 2, 3, and it really takes quite some time doing them one by one. Now what this thing does, it creates a small solder bath, as you will, and you will see, if I'm gonna do this one here, that it goes quite fast. Oops. Yeah, sorry about the smoke. We turned off the dust extractor, the fume extractor, so it doesn't make a ton of noise.
Well, as long as the smoke is not coming from my rack.
Yep.
At home, I'm okay with a little smoke.
Voila. So the whole PCB from this side is now soldered. Then when that is done, so I do inspect my work to see if... So this technique is not perfect. So here, for example, there's a little... It's not a short, but it's something I like to clean up. Then this is okay. And so I typically do four of them at the same time, working through the whole batch. So, and now it's time for the connectors on the other side. So I can put those in the jig. Pull this off. Flip the PCB. And then this goes in as well. Yep.
So what components are you going to solder now?
Also connectors.
Also just other ones.
Yeah, these are male ones, so these fit into these guys. So.
Yeah, you just wipe it.
Yeah, you wipe it over.
I'm sure there's a lot of skill involved, but it just looks like you're wiping it across, and it's soldered there.
It's an acquired skill, but you can master it in a reasonable amount of time. And then there's the final connector. So all these connectors I've soldered now, they have the same height. And but the power connector, that one has a different height, so it's a bit taller, and because of that reason I need a different jig, and that's this one. So, and then I put this on here to hold the power connector. So efficient as this already is, it can still be better, because I'm still using these different jigs, sub jigs. And so in the future, I'm still going to be improving on this, so that for each product, I will have a custom assembly jig that is made by my CNC machine. Okay. But that's still something that's on my to-do list.
That sounds like a true engineer speaking.
Yeah, so even how small this process is, I try to optimize it to the maximum, so that it's still doable in parallel with my full-time job, because this is still very much a side gig.
Yeah, speaking of which, can you tell us a little bit about your day job? I know it has something to do with engineering, but to me that can mean building rockets to fly to the moon, or bridges, or perhaps electric toothbrushes. Mm-hmm. Can you tell us something about that?
Yeah, I have a formal background as an engineer. I have 2 different master's degrees in engineering. One in electronics engineering, and the other one in optical engineering / photonics.
Yes.
And professionally, I'm somewhere between the intersection between optical engineering, electronical engineering, and mechanical design. And so stuff, what kind of stuff do I design? Technical cameras. I work on designing those.
Okay.
Product demonstrators for new technologies. That is very broad. Yeah.
So they're small things rather than very large. You're not designing bridges and.
No, they're always about this. This is the scale.
Yes.
The similar scale to the MS-22. So I'm designing. I'm often also building part of it myself, assembling, and I also often serve as an interface between the specialists of each domain, because there's always a trade-off. I'm not a true specialist or expert in either of the domains, but I know plenty to get most simple things done, and I also speak the lingo of the true experts.
I think that's a really important role, to have someone in the middle that knows enough of everything to be able to explain the things to those who know everything about one thing. Yeah.
So it's a bit jack of all trades, master of none. But the truth is also that you don't really need to be a true master to get meaningful products and have fun while doing it. So
you once told me that you wanted to incorporate a little more of a creative process into your engineering. I guess this applies to both your day job and the things you're doing with Threetom.
I'm very lucky in both regards, in the sense that at Threetom I do whatever the hell I want.
Yeah,
so that's very nice. Also, it's not my ambition to do this full time or make a living out of it, strictly speaking. So I don't have stress of designing products that are very commercial, because it's my ability to eat a sandwich will depend on it. So that's not the case, which is very nice, and I want to keep it that way. And then at my job, it often concerns prototypes that we're building. So I can also often design something nice, because cost is less of a factor at that point. And also often it needs to look nice to attract people's attention to this new technology that we're showcasing.
To appeal to the customer or investor or whatever.
Yeah, it should give them a sense of what this technology could look like when it becomes mature enough to come into your daily life.
So gone are the days of a botched up prototype with wires sticking out.
I try to avoid that.
Okay, so I see you're wearing, it's something I wanted to ask, the bracelet.
That's for anti-static protection. So in the rare event that my body should accumulate static charge, I could touch a component and go zap, and then it might be damaged.
And I guess it's just, there's some metal inside the bracelet, I guess.
Yeah, so here's a metal contact, and that is connected to the ground of the electrical installation here.
Okay, so it's not even just connected to the earth.
Yeah, to the earth.
But really to the earth from the electrical grid.
Yeah. But anyway, so at this point these PCBs are soldered, and then they get depaneled, and then we get to this situation here.
Yeah, so they're all in their separate boxes.
Yeah, and so now I will have to solder the connectors by hand on these depaneled ones, because they don't fit the jig, because I already depaneled them. It's not the end of the world, but this, I swear to God, each time that I do a small run, I forget about this, and yeah, this has happened more than I'd like to admit.
Ja.
Dus dat is met een moesje. Hè. Een moesje is een geweldige techniek. Mannetjes op. Twee keer dezelfde fout maken en doen alsof dat de bedoeling was, dat is jazz, hè. So this is the trick to being able to stack 4 PCBs in such a tight space. So I'm soldering these screws under the potentiometers, and to that the rest of the stack is mounted later on. So solder paste on the screw. And now I'm gonna heat that up with the hot air soldering iron. Well, hot air gun. The trick with hot air is always patience.
So that soldering paste, that's the mixture of the flux and
solder balls. Huh?
And where did it came from?
It's this little device here in the back. It's a Chinese paste dispenser.
Okay.
So whenever I push this pedal on the floor, that paste comes out.
Okay.
Very handy also when you're soldering surface mount components. Alrighty. So after DIYing it now, basically, I think we're ready to start assembling the modules.
You make a distinction between soldering the connectors and...
Yeah, that's part one of the process. And then there's part two, which is the final assembly. So that's soldering the pots, the switches, the jacks, and then screwing everything together. And also the LEDs get soldered. I'm gonna show you that now. So usually the connectors and trimmers and depaneling, that's something that I do beforehand for a whole batch. Then when all of that is ready for assembly, then I will assemble about 5 modules together, and then either store them or immediately test them. Depends a bit on what my mood is and how much time I have.
So it's just part of your assembling process to divide it into separate steps. Okay.
Because this by far per module is the most time consuming step, because there are a lot of manual solder points that are not necessarily suited for drag soldering. So it takes
longer.
It takes longer, and then also I do it with care so that I don't have to come back and fix something. But if I do miss something, that's something that will become clear when we go to the calibration and quality control.
Okay.
Because nothing gets sent out without being properly tested.
Yeah, it's amazing that you make all of these just here inside your, yeah, it's more like a garage, or do you call it your workshop? I mean,
usually it's like, yeah, I'll show you my workshop.
Yeah, I mean, but when I go to my, yeah, it's just the second bedroom really, but I call it my studio.
I like to also call this place Mijn atelier.
Yeah, there's not really, maybe workshop is
it's
more...
like, yeah, Flemish for workshop. But
yeah,
it's also partially because I told you my dad is an optician.
Yeah.
And that's what he calls his workplace, Mijn atelier.
Yes.
And now the part that always makes me feel like a car mechanic. I wish there were more tools for this part, because this is so placing all these washers and nuts is actually quite laborious, especially these guys.
How many times have you knocked one of those boxes on
actually,
the ground?
less than it. I've never spilled one on the floor actually, but I should put these in a different location. I once spilled an M3 hardware kit on the floor at work, and that I spent more than an hour cleaning up. It was quite embarrassing. In the middle of a hallway, I tripped over my own feet, and thousands of M3 nuts and bolts on the floor. Yeah, that was not a good day. So while I'm screwing this in, I'm also holding them from the side so these connectors don't get skewed because of the torsion you put on them.
How do you call a tool like that? Is it a knurled?
A knurled driver bit, I would call it.
Yeah.
Typically, people have this one.
Those are just hex?
They're not hex, so they have these little indexed things on the front, but they're slightly too wide for Donkey Kong nuts.
Okay.
And so that's why at some point I made my own custom tool. This is made out of tool steel. Alright, so then now we get to the second part that usually takes quite a bit of time, and that's soldering all these components on the front panel. And so I'm also soldering the tabs on all of the pots so that they don't wobble. Well, it's two things that makes a pot wobble. Well, three things. Either If the shaft is made out of plastic, that doesn't help. And if the pot isn't screwed to the front panel, that also does not help. And then the third offending factor is not soldering these tabs.
I guess when makers decide not to take those measures, is it just because it takes more time?
It takes time, huh?
Yeah.
You can see that here. If I need to build 5 of these in parallel, so the second part of the assembly process, yeah, it's usually half a day's work.
And if you automate the manufacturing process, like some of the biggest makers in EURORACK,
then you still have other people soldering this by hand for you. So these solder joints that I'm now making, they're very hard to automate unless you're doing huge numbers.
Okay.
Because you need to program a robot and install a robot to do it. There's also a way of soldering these things by dipping it into a bath of molten solder. Okay. But that only works if you don't have extra connectors on the back. So if your module is a single PCB, which is clearly not the case.
Yeah. Yours is 4 layers, right?
Yes. Yeah, it's so people tend to underestimate the MS-22 because it's so small, but it's easy to forget that there's over 300 components and 4 PCBs behind the panel.
I know there's a quite elaborate interview with you on Jesper's channel, the Modular Clubhouse. I will link that interview in the description box, by the way, for people who want to know more about Tom's jazz history and double bass skills.
Yeah,
no spoilers.
Don't imagine too much.
But I know at some point he asked you how many units that are out there in the wild. Just a general guess.
Somewhere this year I expect to hit serial number 1000.
Okay.
Keep in mind that's all DIY kits, naked PCBs and assembled modules counted together. So WASP.
Yeah.
And so it's not 1,000 assembled modules.
No, there's 1,000 PCBs.
Yeah.
Or
in various
stages
of assembly. Yeah.
But all of these went through your hands?
At some point, yeah.
Yeah, that's pretty
to varying
impressive.
degrees. Yeah.
That's pretty impressive.
We're nearing the end of this build.
So you designed this filter around a circuit that was already built, of course, the MS-20 filter.
Well, there's various sources for what is supposedly the MS-20 schematic on the internet, and
that's a whole other rabbit hole.
Yeah, and schematics on the internet are a dodgy thing. So there's all kinds of weird versions of this schematic out there. So what I did was I compiled a architecture that was so I took the best pieces of what I found and then I completely redesigned it myself. By the way, so what's also unique about this is the gain staging. So because there's VCAs between the two filters.
Yeah.
As you turn the gain knob, the gain for each stage, for each filter increases, not just the first filter.
Yeah.
And because of that, you have smooth gain staging throughout the whole setting, the whole range of the knob.
So you're talking about when you're turning the frequency knobs? So
the gain knob. When you turn the gain knob, that actually controls a VCA before the first filter and a VCA in between the filters.
That's what you mean. Okay, so there's one control for several VCAs in several stages of the circuit.
And because of that, the gain is rather smooth at all settings. It is possible if you just drive two filters in series from the front, that it becomes really gnarly at the end of the knob, at the end of the range.
Yes.
And so I like to think that I avoided that by doing it this way. It's a side effect of making the gain CV controllable.
Yeah. From this angle, it looks a little bit like these. Is it Japanese buildings?
The temple style buildings.
Yeah.
So now the finishing touch. We add the knobs.
Are these just knobs? Do you just go on a site and order knobs, just like
I used to, but now these days I get these straight from the manufacturers.
No. But they're not specifically made or something?
No. But I did go through a lot of effort selecting knobs that I like.
Yeah, they're pretty unique, and especially because the module is really cramped, with it only being 4 HP. The feel of the knobs,
they compensate for that.
Yeah, they quite improve the experience, because to be honest, sometimes when the filter is between several modules, it can be a little bit hard. Yeah. But of course that was the challenge that you set yourself, which is something that I really think is really cool.
To some point, so it's a totally valid criticism. Yeah, I'm not going to deny that. However, let me say this. There's also some responsibility to the guy designing the layout of the rack to not put this next to something that conflicts conflicts you reaching into here.
Yeah. I think that's something that people that are new to EURORACK, and I perhaps want to make a video about that in the future, that's the trap they step into. Just cram as much small HP modules into one system.
Yeah.
As long as there's enough power, we can get more modules in, while in fact, now it's easy for me to say I have a bigger system and a lot of big modules, but usually the bigger a module, it's easier to have a little bit of room around around the knobs, and if it's not possible, just put two blanks beside it.
Yeah, or you can still put it in a control module, like the one with the big knobs by Tom Whitwell. That's the total opposite of this, but
yeah.
All right, so well, I think we can go and calibrate these.
Yeah.
And we can finally get from one hot space to the second hot space.
Yeah, I think it's time for to have a drink first. It's getting quite
This is the reason why usually during summer I take a break.
Ik was aan het denken van mij...
Dat is al iets. Dat is al een goeie B-roll.